Good morning, good afternoon, good evening, depending on where you're coming from or where you're joining us. Um, I'm going to present today on making your machine learning model usable by others. So this topic is just going to focus a bit on what Magda said, but more on the deployment side. So you have your machine learning model that is working on your Jupyter notebook, and you know that it has 99% accuracy, but you also want other people to be able to use it and see that it actually has 99% accuracy. So the first thing is, so my name is John Robert. I put machine learning to production at Adriba. So Adriba use machine learning for marketing. And so my major task is a bit of data science task. And then apart from just building the model, we need to also put this model to production for our clients to use them and then to give us feedback on them. And we always improve our model and we treat our model every day. So the first thing to understand in this talk is to understand what usability is in this sense. So in this sense, usability means creating a product for your machine learning model. So you have a model you built already, for instance, you build a classification model or you build an object detection model, then you want to make a product with it. Or in the technical side of it, or in the technical world, how you deploy your machine learning to production. So that's what I'm going to be talking about today. So first is to have an idea of what machine learning is usable in this sense, what machine learning is usable. So we all know, we all use Google Translate or any other translator. And behind this translator, you have the model architecture. Likely most of the time it could be a type of transformer. So you have the model, but this model was wrapped and it created a product, a translator from it. Or another example is in Tesla, you have this neural network architecture, and then this neural network architecture was deployed on the car, and then you can now use this model. So there have been a lot of problems in machine learning because most times we develop our models and our models are working perfectly in our labs, are working perfectly in our university lecture halls, but no one knows how good they are, or no one's used them in reality. And a model that has 99% accuracy but just stay on your laptop is not valuable, because the whole idea of building things is for others to be able to profit from it, for others to be able to use it to solve problems for others. So that's why it's very important to understand how to make your machine learning model usable. To understand what usability is in machine learning, we need to understand the life cycle of a machine learning project. So we have the getting your data, we have understanding your model, building your model. But for making your machine learning usable, you need to understand the deployment of your model. So you have the model well done, properly trained well, but now you need to put it on something. I mean, you need to put it out there for other people to use it. So because I know that we have different people in this event, I would like to make this concept a bit simple. So to make the concept a bit simple, I'm going to compare development of machine learning system to preparing the food. So if you want to prepare food, I know everybody's so familiar with preparing food. So you know you need to get the ingredients to prepare food, you need to cook the food, and then you need to serve the food in a plate. So the serving the food in the plate is what I'm going to compare as usable. So we are serving the machine learning model we already created. So that's what I'm going to compare as usable. So in a better way of saying it, so you source your high quality data, and it can be compared to you source your ingredient. And as we know, if you prepare food well, we always know that the ingredient is the most important part of the preparation of the food. Also in machine learning, the data is the most important part of machine learning. Without an high quality data, no matter how good your model is, it will not perform well. As I said, now we are moving from model centric machine learning to data-centric machine learning, because we know that the data is the most important part of machine learning. So after you get the ingredient, or after you get a good quality data, then you train your model. You prepare, you for instance, you use a transformer or whatever model you use, which can be compared with cooking the food. But if you cook a food, is good, the food is so nice, but you need your friends to eat it. You want them to taste it and see how good the food is. So, and that's when we come to serving the food or serving the meal, and which I compare with deployment. So you deploy the model you have created on your system. Now, as I said, I'm going to compare. I'm comparing an AI system with preparing of food, or yeah. So I will call plates. So plates, in sense of preparing your food, you serve the food in a plate. So in machine learning, you serve your model on a platform. So there are four major types of 4 major ways of serving your food, or of deploying your machine learning model. The first one is on a mobile phone. So you can create an app, a mobile app. For instance, you can see an example on iPhone for face detection, or you can deploy your machine learning model on an iOS, IoT device. So for instance, on a drone or on a Raspberry Pi or things like that. Or you can also create a website and wrap your machine learning model with Flask or with Django, and then deploy it on a website. Or you can also create an API so that other developers can use your machine learning model. So now that we have the plates, you serve your food or you serve the model on the plate. It's on the platform. We need to understand how to present it, which I call the table for serving the food, or for deploying your machine learning model. So your machine learning model is not just going to work on your app on your phone, or just going to work on your IoT device. You need something to put it on, which are those cloud services. So for instance, a lot of people use EC2 for deploying their machine learning model, or you can use Microsoft Azure, or you can also use DigitalOcean Droplets. So this cloud services provides servers and other technical infrastructures for you to deploy your machine learning model. So after we have the plates, we have everything set. We need to understand the difference between the traditional software development and the AI development. So, because you could ask that, since we all deploy normal software, why is it so difficult to deploy machine learning models? One thing that is different between machine learning and other systems is that machine learning contains the model, which we can compare as the code, and data. But in normal traditional software development, we only have the code. What I mean by that is that, for instance, you have a website. So you create the code for a website, you develop the website, and then you deploy the website. So anyone that is going to use a website will just go there and do something. For instance, an example is if you go to maybe Amazon, right? If Amazon, for instance, don't deploy any machine learning model, which I know they actually have machine learning models. You just go to Amazon, you search for what you want, and then you buy. You don't, so that's all you do. You just do something. But on a machine learning model, you just don't do something. It also get the data. So for instance, Amazon, you also use machine learning models behind the scene. So they get the data, they check, okay, what kind of things do you click, and when did you click them? What are you searching on, and things like that. So they get this data, and this data is used again to train your model. So that's why machine learning deployment is a bit different from traditional software development. So now that we know the difference, we also need to see the difference in the deployment phase. So the previous speaker spoke about DevOps a lot and MLOps. So this is like the two different. You can see that the machine learning is adding a new cycle to the normal DevOps that we have. So we have now the model and the data, and then we need to combine them with the normal DevOps we have previously. So you can see this the cycle is becoming a bit more complicated, and that's why most people don't deploy their machine learning model or don't make their machine learning model usable, because it's a more complex it's more complex to do. As we can see, in traditional machine learning models, we already have a lot of tools, and it's really overwhelming. So imagine adding another cycle to this, it becomes a whole lot, it becomes very complicated. But even though it becomes a bit complicated, I'm going to share some of the tools I use, or some of the tools I have seen that are really good. But now I'm not going to focus on the DevOps side, but I'm going to focus just on the majorly on the machine learning tools that we use for deployment or for serving the model. And coincidentally, TensorFlow and PyTorch, they also call it model serving, so it's really interesting. So one tool I've used before is Streamlit. I'm not sure if anybody have tried Streamlit before, but Streamlit is, so you have your machine learning model. Your machine learning model are just code, but for you to make your machine learning model usable, you need to provide a user interface. So Streamlit helps you to provide the user interface, and also we have what we call Streamlit sharing, that after you provide the user interface, it also helps you to deploy your model on a server. So for me, I used to say Streamlit is the fastest way to deploy your machine learning model, because it helps you with the UI, and not only with the UI, and also with the deployment. Another very interesting tool is CML. So this is more for continuous integration, but continuous integration in machine learning. So you have your machine learning model, and you also have your data, and it helps you in automating these the processes, to reproduce your accuracy in production and things like that. So CML is a very interesting tool. One tool that most people use during development and in deployment is this MLflow. So MLflow helps you more in hyperparameter tuning, and then also with the library. So you have different libraries to use for your machine learning project, and then you have different hyperparameters, different metrics. So MLflow helps you to understand and track each of your runs and your hyperparameters. Something also that I've also used DataRobots. So DataRobots is very interesting. This really helps in monitoring of your model. So you have created your model, you need to understand the new data that are coming in, you need to understand what the performance of your model, and then you need to track things like, you need to track all the steps in your machine learning cycle. DataRobots is very good at that. Also, I use this CNVRG. So they call it, I mean, on their website, they say the OS for machine learning. So it's also used for building end-to-end machine learning projects. Then the Kubeflow is more like Kubernetes for machine learning. So it's just to manage your workflow. Then some other major tool, I'm sure most people that do machine learning know TensorFlow and PyTorch. Because of the complexity of deploying and serving machine learning models, TensorFlow now have what we call TensorFlow Extended, where you have the model serving and other ways of storing, of saving your model, and then deploy your model and creating endpoints with your model and things like that. And PyTorch now also have what we call the Torch script, and we have Torch serve and things like that. All these are just a way to help people to deploy their machine learning model so that other people can test them. So if you use, for instance, TensorFlow serve, then you can create an endpoint, and you can then maybe use Flask or something to get send request to the endpoint, and then you get a reply from the endpoint. So to really understand this, we need to see an example of a model that has been deployed. So this picture was taken from Tesla. So Tesla, you have the data, you train your data, then you train your data, then you have your model, you deploy the model, you deploy the model on a car. But as they say, the world changes every day, so you cannot expect, for instance, you cannot expect the data that you have during, if you train your model with data before COVID, and now you're predicting with the data during COVID, it's not going to perform well. So there's a saying that says, as the world changes, you get new data, and then your machine learning model is supposed to adapt to the new data. So what Tesla does is, once you deploy the model on the Tesla, then they find inaccurate predictions. So for instance, you have false positives and things like that. So they get the images. So in this example, Tesla was not performing well on images, or when it's in a tunnel. So they get images from the tunnel, and then they retrain the model based on several images from a tunnel. And with that, it's going to perform better on tunnel image or in a tunnel. So now we need to understand why many people don't talk about the deployment of machine learning models. While deployment of machine learning model is a complex task, because you have a lot of roadblocks. So for instance, we have what we call the data leakage. So during the development of your model, you can train your model on the training data, and you do a lot of things on the training data to get the best accuracy. But sometimes some of the things you use during the training data may not be available on the test data, and this is called data leakage. And if you have data leakage, your model will overfit the training set, but will perform very poorly on the test set. Another roadblock is what we call data drift. So data drift is when the distribution of your input data changes. So for instance, if you imagine the distribution of your data before COVID is different from the distribution of your data during COVID. So that's an example of data drift. Another roadblock is what we call prediction drift. So prediction drift is, for instance, you train your model to predict just cat and dog, but then now you're getting images of a car. So your data don't understand this new target. So prediction drift is when there are new targets in your data that your model was not trained on. Another roadblock is what we call the covariance drift. So this is when you have, so our model learns based by understanding the pattern between your features and then your target. But if there's a change in the relationship between your features and your target, then our model is going to perform poorly. And this happens during deployment, because in deployment, or when you make your data usable, the users are going to put in different things. So that's why we have all these problems like data drift, prediction drift, and covariance drift. And all this causes what we call model regression. So your model was performing very well before, and after some time it becomes a bit bad, and before you know it, your model is performing really, really bad. Another roadblock in deploying your machine learning model or in serving your machine learning model is that what you train your model on is different from the reality. So when you train your model on maybe CIFAR 1000 or on Pascal VOC. These are well-structured data, but in reality, we don't have well-structured data. For instance, this image was taken from a lecture in MIT, and you can see that you have during the training they use very good images, but then the users, when you make your machine learning model usable, then people try to put a lot of garbage and things like that, or on very uncertainty. So there's this saying that says all models are wrong, but some that knows when they can be trusted. So what this means is that we need to be able to, our model needs to be able to tell us when it doesn't understand the image that was given, because in production, or when you make your machine learning usable by others, people are going to try a lot of things. So you need to be able to explain to the user that, hey, what you're giving me, I don't know anything about it. This is what I know something about. So this leads to what we call out of distribution. So out of distribution occurs when, for instance, you train your classification model to predict just cats and dogs. So you have a probability for cat. If you give it cat, you have a probability for dogs if you give it dogs. But what happens when your model, what happens when you give your model a picture of a car? What is it going to predict? In machine learning now, it's still going to predict either it's a cat or it's a dog. So for instance, you put a car, it's going to tell you, hey, this car looks like a dog or looks like a cat. But normally, what we need to do in machine learning in production, or in deploying machine learning, we need to be able to tell our user that, hey, I only know how to predict cars and cats and dogs. I don't know how to predict a car. One of the major problem in deploying a machine learning model is infrastructure. So when you train your machine learning model, you do everything on your laptop, or you use your GPU and you do all those things. But in production, your user don't have GPUs and things like that. Or for instance, your phone or your IoT device don't have so much GPU that when you use in training. So you have a problem of infrastructure. And also we need to also understand that, for instance, when you have a machine learning model on your system, you just do prediction maybe once or twice, or when you do your prediction. But for instance, you have a machine learning model like the one on Netflix, and about 1 million people are trying to access it because you have a new movie. So the infrastructure needs to be able to scale based on the user. So if you have, as I said, on Netflix, you have, because of a new movie, everybody's logged in the same day, then you need to scale your infrastructure. Then maybe during the weekdays, like on Monday, everybody's at work and everybody's tired when they go to work, when they came back from work, so they don't really watch movies. So you need your infrastructure to scale back down. Another roadblock is latency. So you have when you have a model on your computer, only you is accessing the endpoint, or only you is using it. But when you have 1,000 people using it, you need to be able to make it fast. For instance, you don't want a user to wait 10 minutes before you give him a reply. When you, for instance, you use your facial recognition on your iPhone, you want to just use it and get your reply and get a response in less than 5 seconds. You don't want to wait for 10 minutes because you don't want to wait for 10 minutes. So these are the problems, or these are the problems we face when a machine learning model is deployed, or when a machine learning model is made useful to others. Now, I've talked a lot about the problems or the roadblocks. Now I need to talk about some solutions. So one of the major solutions is you need to reduce the size of a machine learning model so that you can be able to put it on an IoT device, like on a Raspberry Pi. So we have what we call quantization. So quantization is the process of reducing the weight. So for instance, in machine learning, your weight could be in 64 bits, and that makes the model really big. So you can reduce the weight from 64 bits to 32 bits, and this is going to reduce the size of the model, and it makes it easier for you to deploy your machine learning model on an IoT device or whatever, or anywhere you want, any platform. Another thing is called pruning. So recently, there's what we call skip connection in ResNet. This is just an example, right? And there are some layers on ResNet that kind of not really useful in it. Useful in the sense that maybe they don't really have a lot of, they don't really influence the accuracy of your model. So you can reduce these layers, and once you reduce these layers, it reduces the size of your model, and it makes your model easier to deploy to production or to make it usable by others. And this could be called model compression. So you are compressing your model to be smaller so that you can use it on, you can deploy it on any platform. Another major solution is especially when it comes to data drift and prediction drift and data leakage, is to have a dashboard where you can monitor your data. So this dashboard was from DataRobot. So you have, as your new data comes in and people use your machine learning model, you can monitor when there's a model degradation, when your model is not performing well again. You can monitor what kind of data people are putting in. You can monitor the hyperparameters. You can monitor a lot of things, and this will help you in deciding what to do, and if you need to change your model and things like that. And one major thing that is different from what we do when you don't deploy your machine learning model or when you don't make your machine learning model usable is retraining. So retraining is, as I said before, you have a model trained on data before COVID, and now there's COVID. You need to retrain your model. Every time you have new data, you need to retrain your model. So in production, most of the time, like for instance, Tesla, as I showed you before in the image, Tesla trains their model, they train their model when they have inaccuracy. So you need to retrain your model frequently. This is not done generally in when you don't deploy your machine learning model. So basically, this is what my talk is all about. So what we have spoken about today is on the roadblocks on making your machine learning models usable, and on the solution of making your machine learning model usable. So basically, to make your machine learning usable, you need to deploy your machine learning model on a platform like on a phone or on a website or on a IoT device or as an API. And I hope in future, most of us will be able to deploy our machine learning model for other people to use, and so that we can make the world a better place. If you have any question, you can ask.
So, any questions? I guess I again need to jump in with my comments. Thank you for the great presentation, John. As a person who's making the first steps in the machine learning path, it's very insightful to look at what it looks in production like. So probably my I know something about model compression, and I can estimate how much it takes from the hardware to use the models. Like, for example, when you deploy something to recognize the voice on Raspberry Pi, or something to recognize images, probably on something smarter than Raspberry Pi. Probably you can share some real-world examples that you have in that you had in your career on your job.
Okay, so before I joined Adriba, I worked in Mercedes in the self-driving car project. So during this my time in Mercedes, I was able to understand that having the best accuracy is very good, but putting this model on a car is a whole lot of challenge. Because, for instance, your car don't use Microsoft or don't use Ubuntu. Your car use things like ROS, Robot Operating System. So you need to understand that you need to understand how to make this model functional on a car. And something that is also different is that your car don't have 10 gig RAM. Has your car has more component and it's not meant to be a computer. So you need to find a way of um, compressing your model to be to be able to fit into this car. And also you understand that in the complexity of a self-driving car is that you cannot wait for 2 minutes before you take decision. You need to take decision almost immediately. So you don't want a model that needs to run 5 seconds before it takes decision, then you have killed 5 people already before that. So these are like one of the major problems with putting your machine learning in production. And we also see some of these things in, I mean, you have a lot of biases on maybe on YouTube or on whatever, where you see that the machine learning model was trained on something and then it's predicting something else. So in real life, it's really much difficult task when it comes to deploying a machine learning model, because you need to think about the infrastructure, you need to think about the size of your model. And naturally in machine learning, the bigger your model, the more accurate your model is. But now in reality, you need to reduce that. So the less the model now, then these are like trade-offs that happens when you need to deploy machine learning into production. There's something that is a bit more challenging is many data scientists understand how to improve your model, but they don't understand how this model is going to work. For instance, you have an image classifier and you put it on a server. Now it's a bit difficult to just send JPEG or you send PNG from a server to the front end and things like that. It's much difficult. So you need to convert the type of the model of the type of the input data you get before you can use it and before you can use it in production. I also need to understand that their latency, and people don't want to wait for 3 seconds before they get the result. They want to get the result immediately. So there are lot of challenges when it comes to deploying machine learning model, and that's why a lot of people don't do that, because it's easier to just give a paper and say, hey, my paper has 99% accuracy, because of course it's trained on Pascal VOC. For instance, recently I just did a small project and I deployed a image classifier using Silver 100 and Silver 1000, and I gave my friends to use it. And of course, users or people that are not technical, they want to do something crazy. So a friend of mine will just put a black image, like black, and then of course the machine learning model is supposed to predict something, so it does predict something really stupid. Or for instance, one of them tried something like there are some objects that are very there are some objects that are very new. For instance, a new type of artwork. So one of them snapped an artwork that has like something really funny on it, and then it predicted mosquito net, and it's like, hey, your machine learning model was not working. And I said, of course it's not going to work well, because this thing is not even common, and things like that. Some of the challenges we have during in machine learning. And another challenge we have, just like the previous presenter said, is MLOps. In MLOps, you have the research. In research, we have been so focused on improving the architecture. So we have the transformer, you have YOLO for object detection, and a lot of that. But the most important part of a machine learning project is the data. And if you watch Andrew Ng has been talking a lot more about data-centric machine learning and not just model-centric machine learning. So you need to, it will surprise you that if you improve your model, you clean your model more. If you improve your data, you get a better quality data. you get higher accuracy than just improving your model. So, and a lot of people have been so focused on, hey, I want to use the state of the art machine learning model instead of focusing on, hey, we should clean this data, we should make this data, we should get better data, we should get better features, and this is going to increase our accuracy. So these are like some of the these are some of the things that are happening now in machine learning that needs to be changed.
There's definitely a rule: shit in, shit out, right?
Yeah.
Oh yeah. Can you provide us with some estimate? What is the size of the input data set? Like probably not data set, but the parameter set to the data model. And what is the typical size of the data models that you, like, of the machine learning models that you deal with?
So it depends on the situation of things. So generally, we know that image data, image classifier or anything that has to do with image is more. You have more parameters and things like that. So, for instance, when I worked in when I was an intern in Mercedes, we have in 1 minute of drive, you can have 5 gig of data. In 1 minute of drive, you can have 5 gig of data. But now I'm working more with time series data. So we get data from marketing data, from ads and things like that. So these data are less, they are not as big as what we get in images. So I would say it depends on the kind of model you're working on. But if you're working with things like NLP, like natural language processing, if you're working especially with images, you have millions and billions of parameters. But if you're working more with time series, you may not have those kind of you don't need that. You don't need it's not that complex. I mean, it's complex in the modeling because in time series now you need to think a lot about the time, a lot about seasonality, a lot about things like that. But in computer vision, you don't really think about seasonality and things like that. You need to think about the data itself and point cloud data and things like that. So point cloud data is also really, really difficult to model. So I would say that it's really difficult to answer the question, but depending on the situation or how complex your the task is, then it depends on the then you get the hyperparameter. But I would say that generally, I think images and point cloud could be more complex than maybe time series. But time series, you could also think about it. It depends on the they call it velocity of the data. So velocity of the data means that imagine you have Netflix, and in Netflix, 1 million people are sending the data, are doing something in every 1 minute. So it's a lot of, you have a lot of data. But in advertisement, it depends on how big the company is, and so it's a whole lot of for instance, you're working on a farm, and on a farm you have like data for temperatures and things like that. So the way that works is also a bit much different, because I once did a competition where we have data, temperature data and other data from a farm. Then you create a model based on this data, and it's a bit much. You don't have so much of complexity in sense of the model size than when you have in images.
Yeah. Maybe someone else wants to jump in with questions. I don't want to take all the bandwidth. Raise your hands, guys. The topic is very interesting, and the speaker is marvelous.
Thanks
no
so
other
much.
chance to talk to such a nice person about interesting subject. Okay, then maybe another question from me. Like, there's actually more than just machine learning model when we are talking about especially real-time image processing. There is some pipeline of things that happen before the parameters hit the model. Like there's feature extraction, there are some image processing. Is there any insight about how do you update this part of things? Like I believe in machine industry, there should be some things that are just hardwired, and there are some things that can be updated with a software update, and there are some things that can be updated just by changing the machine learning parameters, right?
Yeah. So, for instance, what the previous speaker said, she mentioned what they call feature stores. So, feature stores is in a machine learning lifecycle, you have the data. So, you have raw data, like raw data. Then you need to do some filtering of the data. You need to do some engineering of the data. You need to remove some columns in the data and things like that. So in ML ops, you kind of in the data pipeline thing in the ETL, they call it sometimes they call it the ETL part of things. You kind of do this featuring and then removing some part of the data and things like that. So now I think most of the time they are trying to automate that because in every task or in every project, this is different. You cannot fully create. Yeah, I think SageMaker has something that you can do, that you can actually call some functions to do some things at a particular time. But for instance, if you working with image data on a self-driving car is different from image data on farm, is different from image data for facial recognition. So you cannot just create a custom pipeline for everyone. Everyone needs to, and kind of, even if you are doing the same project, sometimes you need to filter your data differently because maybe you get your facial recognition based on some smiles and things like that. Some other people focus on some other part of the image, so you do your stuff a bit different. And apart from that, what is also very important is the data source. So if the data source is from a webcam, then the webcam is not as clear from a data from a phone. So you don't expect to do the same feature engineering on things like that. So I would say presently in machine learning, there is no one way of doing things. Everybody try to do their things differently. And another thing you need to also understand, or we need to also understand, is that machine learning models these days sometimes have a specific, for instance, if you have a specific size for the image. So if you have a machine learning model, you just don't. So as I said, I deployed something for my friends, and then somebody is going to bring an image of 1000 by 1000. Another person is going to bring an image of 20 by 20. And then you need to find a way of dealing with all these kind of funny things that happen. So there are a lot of tools to do this, and that's why a lot of companies are focusing on feature stores. I've just been exploring that. So they call it feature stores, where you can save the features from the previous training, and then you kind of understand the features and things. And I really don't understand how that works now, but a lot of companies are focusing on feature stores instead of just focus on the hyperparameters, because now we have what we call transfer learning, where you can just get a model that is working already, then you just add some things to it and use it. So you don't do a lot of hyperparameter tuning like we do in the past. Google and Microsoft and Apple already create the model. So you just use those model, you use the hyperparameter they already set, or from Stanford, whatever, and then you try to focus more on your data and then on the feature engineering.
Yeah. By the way, talking about the example when you fed to the model which classifies the dogs from cats, like some rubbish, some black screen, like I don't know,
Yeah.
it would make sense to introduce some other classes so that the model doesn't get confused so easily, like probably like class not a dog, neither a cat, not a dog. I don't know.
Yeah, so now there is this thing they call out of distribution. So out of distribution should be, I mean, I've not seen that in production, but out of distribution should be like, if you give me something I don't understand, I should tell you I don't know what this is. So you just classify cat and dog, then you give me a lion, I should say, hey, this is not a cat, this is not a dog, it's something I don't know. But it's really difficult now because in machine learning, you need to give a probability of either it's a cat or it's a dog. So it's going to predict a cat or a dog somehow. So that's like a major, and that's why we have a lot of biases, because I mean, I read something on Facebook today that, yeah, in Facebook, they remove some words, like you have groups on Facebook and they need to filter some words and things like that. So you have this group of farmers that they use OL as like HOES in the words, because they use OLs as a tool in farming. And then the Facebook algorithm blocked them because it thought OL was OL in a different sense. Yeah, so it's really kind of difficult to do that now in production. I don't know people that are doing that, but it's really difficult to do that in production now.
Yeah. Okay, I guess we are running out of time. Thank you so much, John, for taking part in this conference.
Yeah,
Thank
so
you.
much. Yeah, have a nice day. Yeah.